Hi, here we are going to see about the Unit 4 in database design and management. And the topic of Unit 4 is physical database design and query processing. And these are all the important topics or subtopics of Unit 4, which is RAID and file organization and how the records are stored stored and organized in files, and indexing and hashing, and B plus tree, B tree, static and dynamic hashing, and query processing, how the queries are processed, um, and algorithms for select and join operations, query optimization using heuristics and cost estimations. And the main topic is RAID. RAID means redundant array of independent disks, and it is one of the combined of multiple disk storage. We can store the data in multiple disk to increase the performance and to increase the redundancy. Okay, and in if you store the data in a single disk means we can face major two problems. That is, if you store a data in a single disk means if the single disk failure occurs means the whole system fails to perform. All your data is stored in one disk means if it gets hurt, damaged, or crashes, or whatever it is, you will lose all data and the system will cannot work further. Okay, and the next one is if too much of data is stored in one disk means it becomes slow to perform operations like read or write data, and some system decreases and some systems performance will decreases, so that we go for RAID. Okay, and how the RAID works means RAID uses multiple disks together instead of one. Data is copied or shared across disk. If one disk failure, data is still safe in another disk, and the work is divided to perform faster. Okay, and if if you have a data and the data is split into the small blocks and stored in a multiple disk. Okay, and these are all the important terms we use in RAID, like mirroring, and meaning for mirroring is exact copy of data is kept on another device. We use mirroring concept in RAID 1, and the parity bits which is used in RAID 5 and 6, and it is a calculated value like a parity block is stored to allow data recovery. Okay, if you fail to recover data, it is not good thing like that. So it is easy to recover if we use RAID 6 and 5. Okay, and fault tolerance, like of meaning of fault tolerance is, for example, if you lost one drive means a RAID uses the another type like a parity bits or mirroring disk to recover those missing data. Okay, that is the thing for fault tolerance. And here we have 6 levels like 0, RAID levels, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5, and RAID 6. And here RAID 0 is also called as the data stripping. Okay, it is the method where data is split into pods and stored across multiple disks. And RAID 0 is used to improve speed performance, but it does not give any safety or no backup. Okay, here we see let's imagine if we have a D1 to D6 data. The data will store, D1 is stored in a disk 1 and D2 is stored in a disk 2, and same time disk D3 is stored in disk 1 and D4 is stored in disk 2, and D5 is stored in disk 1 and D6 is stored in disk 2. Okay, so let's see any example like suppose you have two disk means your data is divided like disk 1 and disk 2. Both disks work at the same time, so it becomes faster. Okay. Okay. Next problem, major problem in disk RAID 0 is if one disk fails, all data is lost. Let's say if disk 1 fails means from that disk 2 we cannot recover the whole data. Okay, we cannot recover the disk 1 details and we cannot recover the whole data. That is the major disadvantages of using RAID 0. Okay. Okay, next we are going to see the RAID 1. RAID 1 means same data is copied and stored in two or more disk. Then this is called as data mirroring. It gives data safety in higher rate, okay, but it uses more storage, like it uses the duplicate copy so that it consumes more storage. And how its work means, suppose you have two disks, means disk 1 and disk 2. Disk 1 is the original data and disk 2 is the exact copy of the same data. Like we here in disk 1 we have a D1, D2 and D3. That is the data 1, data 2, data 3. And the disk 3 is the exact copy of disk 1, like a D1, D2, D3. And in disk 1 it is the original data and disk 2 is the exact copy of the disk 1 data. Okay. Okay, let's go to the real-time example. Like imagine if you have write notes in your notebook means RAID 1 is like writing the same note in two notebooks. Writing the same notes, like writing the database notes which I given to you is in written in two notebooks. Okay, if one notebook lost means you will still have another one, right? That is the example for using a RAID 0. Okay, the main advantages is if one data is failed means data is still safe in another disk. Okay, so the systems continue to work. Okay, the major disadvantage is it consumes more storage and it's expensive, highly expensive when compared to the RAID 0. Okay, and here we are going to see about the RAID 2. RAID 2 stores data by splitting it into bits, like very small bits, and spreading it across multiple disks. And it uses the error correction, which is Hamming code. Okay, some disks store data and some disks store error checking informations. Okay, and how it works means data is divided into bits like zeros and ones, and each bit is stored in different disk. Extra disk store error correction codes. If any disk fails means the system can rebuild the data using those codes, which is Hamming codes. Okay, and here is the diagram for, here we have a two disk and the third one is error correction code. Okay, we have A and B data and error correction code for A and error correction code for B. Here it in error correction code for A corrects the error which is in the A data, and error correction code B which corrects the errors. If the B data has the errors means it clears the errors in B. Okay, that's why we use the error correction code. And let's say example for using RAID 2 is let's imagine if you write a word like data, instead of storing whole letters, each letter is broken into tiny parts like zeros and ones bits. Okay, stored across multiple nodes. And some notebooks store extra checking information. So if one notebook is lost means you still rebuild the word using the extra informations. Okay, so that we use RAID 2 by using an extra informations of the data, we can recover the original data easily. Okay, and important one is RAID 2 is very complex when compared to the RAID 1 and RAID 0. Okay, so that it is not used in most of the time. And next we are going to see about the RAID 3. RAID 3 stores data by splitting into the same pods but in bytes. Okay, and RAID 2 storing the data in a small parts as bits, and here with splitting it into the small parts using bytes. Okay, and splitting them across multiple disks, and one extra disk for parity, that is used for backup informations. Uses stripping, like splitting the data, and uses one dedicated parity disk, and it gives the good speed and some safety. How it works means, if suppose you have three disks D1, D2 and D3, means D1 is the data's first part and D2 is the data's second part, and D3, like that is disk 3, is the parity bit. Okay, parity disk. If one disk fails, means data can be recovered using parity. Okay, and here is the parity bit generator. Okay, here we have three disks, and one disk is disk 1 A B information we have, and disk 2 we have A B, and disk 3 we have parity bits. Each and every data has the parity bits. Okay, for here we have a parity bit of A and parity bit of B. Okay, and next we are going to see about the RAID 4, which stores the data in blocks like large chunks across multiple disks, and uses one separate disk to store parity, which is backup information. Uses the block level stripping, like RAID 3 is the byte level stripping, and this is the block level stripping, and it has one dedicated parity bit. Okay, it provides the same safety and decent performance. Like suppose you have the 4 disk, means disk 1 we have the data block A, and disk 2 we have the data block B, and disk 3 we have the data block C, and disk 4 we have the parity, which is extra backup informations about the datas. Okay, if one data fails, means data can be recovered using the parity bits, which is extra informations about the datas. We can recollect the original data from using the disk data as well as the extra informations. Okay, let's say examples like if you are writing a big assignment, means you divide it into a 3 parts, like friend 1 writes part A, and friend 2 writes part B, and friend 3 writes part C, means one friend can keep share. Okay, share them within themselves, and that is a major plus in RAID 4. Okay, and we are going to see about the RAID 5. In RAID 5 is the data is stripped across multiple disks at the block level, and parity informations. Here we are going to see about the